Hello, this is John D. Callahan. If the observable universe were shrunk down to the size of this room, fortunately, it would not be as messy and discombobulated as my room. However, if it were shrunk down to this size, then the size of the local group of galaxies would be about the size of the tip of my pen, or 1 millimeter. Our galaxy, the Milky Way, would be the size of one of these little specks, about one of these little specks that you can see, about 1/100th of a millimeter, or again on this scale, the size of the local group within this room, representing the entire observable universe. Now, we can imagine the entire universe being a four-dimensional space-time envelope curved in on itself. An analogy would be the three-dimensional Earth curved in on itself. Now, we know the three-dimensional Earth is quite large on this scale of this room, and we can't really measure the size of the Earth by measuring the curvature within this room because the Earth is so large. Similarly, we can't really measure the size of the universe because the curvature of space is so flat and it must be so large. We can set a lower limit, however. We can measure the curvature of space, and we can conclude that the smallest that the universe can be, and when I say universe, I mean the entire universe. If I mean the observable universe, I'll say observable universe. The entire universe has to be at least 250 times the observable universe. Since volume goes as the cube of length, that means there are approximately 15 million parallel universes, in the sense that the entire universe is 15 million times the size of the observable universe. Getting back to the observable universe, the number of galaxies, would be approximately 1 trillion times that little speck representing our universe, the Milky Way. So there'd be about 1 trillion little specks in this room, arranged in arranged in clusters of galaxies, superclusters, and large filaments. The number of stars within the observable universe is approximately 10 to the 23, which is approximately the number, within an order of magnitude or so, the number of molecules in a glass of water, and also the total number of grains of sand on the Earth. Now, there are estimates of the entire universe being approximately 10 to the 23rd the size of the observable universe, rather than 250, which again is a lower limit. And that's based on some assumptions about the universe and inflation. So that is obviously an unimaginable number, but it's not infinite. It's finite. As large as it is, it's finite. Now, an infinite universe, when you stop to think about it, really doesn't make any sense. We know that the universe is finite in time by being 13.8 approximately billion years old. And we often compare a human lifespan to that and say, oh, it's so short. Well, in a sense, it's so long. I mean, if a billion is 10 to the 9, so 10 billion approximately, and we're speaking in orders of magnitude, is 10 to the 10. So you got 10 to the 10 billion years, and yet a human lifetime, if you approximate it by 100 years, is 10 squared. So that means it's 10 to the 8. If you divide the age of the universe by human lifespan, it's only 10 to the 8, which is 100 million. So it's actually not how short a human lifespan is, it's how large. When we're talking about 10 to the 23, or as a chemist would say, a mole. So these numbers are just fascinating, incomprehensible, yet finite. The universe is finite, but even again on the lower end, there's approximately 15 million parallel universes within the entire universe compared to our observable universe. So unimaginable, created by God, who is infinite, and infinite is a different concept. It's an entirely different paradigm. No matter how big a number is, it's still finite compared to an infinite God and compared to infinity. Now, talking about molecules, again, 10 to the 23 water molecules in a glass of water. Now, each one of those molecules is hydrogen and oxygen, and they're composed of protons and electrons. We used to think protons and neutrons were fundamental, but they're not. They're actually composed of quarks. And they have quantum states and so forth, so you can imagine the complexity at that scale and the number at that scale. So it's just unimaginably large number multiplied by unimaginably large number, but yet created by an infinite God. Unimaginably complex. Thank you.